So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now from today onwards we are going to solve a problem related to recursion. So let's stick with the basic first, that here we are going to find that factorial of a number. Okay, so let's see that what a factorial is. So let's take one number that 3 and we want to find the factorial of that. Okay, so what we basically do, 3 into 2 into 1, that will be 6, right? So let's say take 5, it will be 5 into 4 into 3 into 2 into 1, that will be 120, right? So here we can see that we are decreasing the number one by one, okay, and then we are multiplying it. Okay, so this can also be written as 1 into 2 into 3 into 4 into 5, that will be also 120 only. Okay, so if you want to code it, the pseudocode will look like this. Initially, if fact will be 1, then using the for loop in which I will be running from 1 and it will be gone till less than equals to n. Okay, now here in this for loop I will be having fact equals to fact into I. That's it. And in it, after that return fact. So this is a pseudocode in an iterative manner to find a factorial. So instead of doing this, okay, we can also reverse it. That means starting the number of I from n and it will be gone till less than equals to, sorry, greater than equals to 1. Okay, so this can also be done. Both are same. But since we are learning recursion, okay, let's see that how we can find a factorial of the number using a recursion. Almost everybody knows that what is recursion. It is nothing but a function calling itself. Okay, but the actual definition will be a function calling itself to solve this sub problem. Okay, now yeah, let's say if you want to find the factorial of 6, it will be nothing but 6 into 5 into 3, 4 into 3 into 2 into 1, right? But we already know that what is a factorial of 5, right? It is nothing but 120. Okay, so when we got to know that the factorial of 5 is 120, okay, why we have to multiply all this again? Okay, we can simply get 120 and multiply it with 6, so that will be 720. For 7 as well, we can simply have 7 into 6 factorial. For 8, we can have 8 into 7 factorial. So keeping this observation in mind, okay, so let's start with 5 again. 5 factorial. Okay, this will be nothing but 5 into 4 factorial. But right now we don't know that what is a factorial 4, right? So for this it will be 4 into 3 factorial. For this it will be 3 into 2 factorial. For this it will be 2 into 1 factorial. And everybody knows that what is the factorial of 1, right? It's 1. But let's say if someone put the value of n as 0, we know that the factorial of 0 is nothing but 1. So due to that, here also I'll go one step forward, so it will be 1 into 0 factorial. And now the value of factorial 0 is simply 1, right? So since the value of factorial 0 is 1, okay, so 1 into 1 will be 1. So the value of this will be 1. So 2 into 1 will be 2. So value of factorial 2 will be 2. So 3 into 2 will be 6. So value of 3 factorial will be 6. 4 into 6, this will be 24. And 5 into 24, this will lead to 120. So using this only, we are going to design an algorithm that solves the factorial of a number using recursion. So here is the function int fact by passing the value n. Now inside this, we are going to have return n into fact of n minus 1. So here we can see that we are calling this factorial again and again. Okay, and here we can see that it is nothing but n minus 1, n minus 1, and so on. So due to that, here I have written n minus 1. Okay, and that will be multiplied with value n. But while designing any program using the recursion, we need to consider the base case. Otherwise, it will be leads to infinity and there will be a stack overflow. So here the base case will be if n is less than equals to 1. So at that time, simply return 1. So this is the base case, or we can say anchor condition. Okay. Now the thing is that I already explained you that how to solve the time complexity when there is a recursion in the previous lectures. So I'll put down in the description box that how to find a time complexity when there is a recursion. So here the time complexity is nothing but order of n. Okay, and comment it down that what will be the space complexity of this problem. Okay, now let's dry run this code. Okay, so whenever the recursion will happen, it will be done with the help of stack. So let's observe that this, let's say that this is a stack. Initially there is a main function that is calling fact of 5. Okay, now here this will be fact of 5. The value of n here is n, sorry, the value of n here is 5. Okay, keep in mind. Now with the help of this code we are going to dry run it. Now here the value of n is 5, right? So we will check whether n is lesser than 1. No, it's not. So we are going to execute this line. So return 5 into fact of 4, right? This is nothing but fact of 4. So I'm writing in short manner. So now this is a calling. So I'm going to call this fact of 4. Now again we are going to check whether here the value of n is 4 now. Okay, so we are going to check whether 4 is lesser than equals to 1. No, it's not. So again we are going to run this line. So here return 4 into fact of 3. So again there is a function calling fact of 4, fact of 3. So let's call this fact of 3. Now it will check whether 3, here the value of n is 3. Now it will check whether 3 is less than equals to 1. No, it's not. So execute this line. So return 3 into fact of 2. Then again it is a function calling. So fact of 2. Here the value of n is 2 now. Again it will check whether 2 is lesser than 1. No, it's not. So so execute the next line, that is return 2 into fact of 1. Again there is a function calling. So fact of 1, here the value of n is 1. So again it will check whether n is less than equals to 1. Yes. So return 1. So the value of f of 1 here is 1. Okay, so this will be written to 1 and the value of this will be 1, and due to that it has been written successfully. So this will be popped off. So here we can see that 2 into 1, that will be 2. So the value of f of 2, that means fact of 2 is 2 now. So it will be returning 2. Okay, and this will be popped off. So here the value of f of 2 is 2. So 3 into 2 will be 6. So it will be returned to f of 3, that will be 6, and this will be popped off. Again, the value of f of 3 is 6. So 4 into 6 will be 24. So it will be returned to f of 4, that is 24, and this will be popped off. Again, it will be doing 5 into 24, that will be 120. So it will be returned to 1. It will be returned to the main function the value of 120, and it will be either print out or it will be used on another function or values. Okay, so in this way the recursion is happening behind the scene. I hope you got this. Okay, so if you don't, I recommend you to please try run it by yourself. Okay, so I'll see you in the next video. Till then, keep practicing. Thank you.